Hi, welcome to online tutorial videos from JCBRO Labs. For more information, you can visit us at www.jcbrolabs.org. So in this video, we will talk about how to write a program for MSP430 using Code Composer Studio. In order to demonstrate program, we are using the Texas Launchpad for MSP430 G2231 microcontroller. So we will look at it. So here is our development board, Texas Launchpad, which is available to us. So we will be testing our code on this. The benefit of this Texas boards is like debugger is also available, directly available on it. So we can do a real-time hardware debugging using Code Composer Studio as well. And this is the small IC, which is MSP430 G2231. Okay, so let's have a look. We will write a simple program of turning on the LED, right? So prior to that, let's see how the LED works. So yeah, if we talk about simple LED program, so LED's connections should be known prior to us. Okay, so simple LED can be connected to any circuit like this. Here this is the LED, so this is the representation of LED, and here's the resistance. We can say it R. So this particular resistance is known as the current limiting resistance, right? And here is the this particular LED is directly available on the board, and this particular LED is connected to pin 1.0. So P1.0 means port 1 pin 0. So if we send here, right, so if we send here 1, that means plus 5 will be applied to this pin and this LED will start glowing. If we send 0 to P1.0, a 0 volt will be applied here and this LED will be turned on. So this is a simple program. Now in order to write a program for MSP430, as we know working with while working with the Atmega series or some other microcontroller, you know there is a direction register. So similarly here as well, there is a direction register for each port, and that direction register is specified PXDIR, where X could be the port number 1, 0, 2, 3, anything. So because we are using this port 1, so we will be using P1 DIR to specify the direction of an individual pin, right? So when we are writing like this, so this is the structure. Okay, so this is 0 pin, 1 pin, 2, 3, and so on. So if we write 1, so 1 is specify that particular pin to act as an output. If we specify 0, so that particular pin acts as a input pin. So because right now we want to turn on the LED, so we will write 1 here and we will set this particular pin as an output pin. Okay, so this was for setting up the direction. Now the second thing is now when we want to send any specific data on it. So specific data, in order to send the data to the any pin, there is another register that is PX out. So again, X specify here the pin number. So for us, we will be having P1 out. Okay, and if we go to the register diagram of this P1 out, it will go like this. Okay, pin 0, 1, 2, 3, and so on. And this particular pin is connected to LED. So if we write 1 here, this LED will turn on, and if we write 0 here, this LED will turn off. So our code to turn on the LED will become like P out equals to 0x01 to turn on the LED, right? And then to turn off the LED, it will be like P out equals to 0x00. So by writing this, our LED will be turned off. So this is a very simple program. Now let's see, let's write a code in Code Composer Studio. Okay, so let's open it. Okay, so this is already program. We will create a new project. Go to new CCS project, and then MSP430 G2231. You have to select it. If it is not selected, we will use the default location, and then we will type the project name. So let's type the project name as uh, led underscore jcbro. Okay, collect it. Let's finish. So a folder is created, a project is created by the name of led underscore jcbro, and this basic program will be created. Now it already include this watchdog timer. So watchdog timer is a timer which is inbuilt to the microcontroller, which keeps on resetting the microcontroller at an regular interval. Okay, so it is by writing this command we have already reset the watchdog timer. Now going to writing the code. Okay, so as we discussed, we first write p1 dir equals to 0x01. So by this, making p1.0 as output. Okay, now we will write a while loop. So as you are familiar with the embedded programming, I'm guessing, while loop, whatever code we want to keep on running continuously, that code goes in the while loop. So it is an infinite while loop. So this particular code will keep on executing. Otherwise, the code will run only for once. Okay, now we will send the data to out. So p1 out equals to 0x01, and then there is a command delay underscore cycles, and then we have to provide the number of cycles for which we want to provide the delay. So these are the machine cycles of the microcontroller. So what exactly machine cycle is like? It is the internal clock of the microcontroller. So if you are using the internal clock of 1 megahertz, then one cycle corresponds to 1 microsecond. So by writing these 1 into 10 power 6 cycles, we are providing a delay of around 1 second. Okay, so this particular function is inbuilt to the CC Code Composer Studio. By doing things, we are providing a delay of 1 into 10 power 6 cycles, and then after that we will send 0 here in order to turn off the LED, 0x00, and then underscore delay underscore cycles. Okay, okay, let's save it. Now let's compile it. So we'll go to project and we'll go to build project. So a project is created. Now in order to generate the hex file, we have to go to the project and right click on it and go to the properties, because by default it doesn't generate the hex file, and then we have to go for here hex utility MSP430, and then we have to click this option, enable MSP430 hex utility, apply, and then close. Okay, now compile it again, build project. So build is finished, hex file is generated. Now we will demonstrate the debugging option, right? So let's create a little bit bigger so that it is visible clearly. Okay, now it is fine. So debugging means we run one command at a time, and the corresponding action will be seen on the hardware as well. So we'll click here on debug. One more thing, during the debugging session, these we will omit this, because what happens, function got stuck into that. Okay, so now let's run the debugging. Okay, we will have to compile again. Okay, now debugging. So it is opening a debugger. Yeah. So all the registers are available here. You can see all these registers. If these are not coming up by default, go to window, and then you have to show view here, click on this register. So all the internal register of the microcontroller will be available here. Okay, so now we are using port 1 basically. So if we click on port 1, these are so many registers which are associated with this port 1. Okay, now we will run the command again. So whatever this highlighted command is, that particular command will run. So we click on it. This command has run. Now this one is, we will click here, step into. This command has run, and if we go to P1 dir register, where it is, here, you will see P0 has become 1. Okay, now we'll again click. Now P1 out has become 1, right? And similarly, LED has turned on the hardware. So right now we are in the debugging mode. So microcontroller is getting the data from the debugger and then executing that particular command on the hardware. Now if we go it will execute 00, so it will turn off. So we click it. Now register value has turned off, and so the LED has turned off on the hardware as well. So let's click it again. P1, now turn on, turn off. So our code is working fine. So now that's good. Now let's stop the debugger. So generally debugger is used to verify whether the code is working correctly or not on the hardware. Okay, now sorry. Now we will run the code directly. Okay, first we will build project again because we have added these delay cycles, and then now we will, because we have already generated the hex utility, so we will simply download the hex file on the microcontroller. So in order to download it, go to run, click on load, and then click on the project file. So this led_jcbro was our project file. Just click on it. It will download the code on hardware. Once it is done, now you can see the hardware. It is blinking at rate around 1 second. Okay. Now, what happened? Let's change this number of cycles and save it. Now let's compile it again and run it again. Download the program again to the hardware. Okay, now LED is flashing at a faster rate. Okay, so this is how you can create good applications, right? And you can use this particular code composer studio for writing a different programs for MSP430 microcontroller series. Okay, so finally, we also provide online training, helping technical assignments. We also do freelance project based on data science, Python, machine learning, embedded system, image processing, etc. So if you have any such requirement, then you can contact us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. So that's it for this video. Thank you.